by many measures, it is actually the most successful theory in the history of science in terms of how well it matches our experimental results.
And yet,
quantum physics says that atoms and subatomic particles behave in odd ways. It says that they can seem to be in two places at once, or, behave both like waves but also like particles. If you just look at the math of quantum physics, it actually doesn't say that these strange behaviors in the small world will go away when you get to the big world. And yet, I never find my house keys in more than one place at a time. I never find myself in more than one place at a time.
That'd be so much more fun, though.
It would be so much more fun. So on the one hand, it explains all of this stuff about our world. But on the other hand, it's not clear what it's saying at all. So what's going on? What is real?
Dun, 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 dramatic music.
So then the question is, okay, well, if the laws of quantum physics apply at all scales, then what's going on? And that's a question that has been answered in several different ways with several different interpretations of quantum physics.
Other universes, right?
Yes. So one of them, probably the most famous one, other than this, shut up, go away option, is the many worlds interpretation, which was first developed by Hugh Everett, a physicist in the 1950s.
The many world stuff's really hot right now, like with Spider-Man. There's all the Spider-Man stuff with the multiverse.
Yes.
It was our original documentary.
That's it, we sparked it off. But is there... but it's not testable, right? So it fits really well in the realm of science fiction, but is there any way that you could test the many worlds?
Well, if you're saying, is there a way to test the many worlds interpretation versus other interpretations of quantum physics? Not really, but that's just for now. Someday we'll have a different theory, and that different theory is going to make different predictions and have different interpretations, and could easily give us a different way of thinking about or even testing the many worlds hypothesis. And it goes in the other direction as well. The new theories that we come up with are dependent on the way we think about the theories that we have right now. Someone who is a many worlds person is going to come up with different new theories about the universe. Like a physicist who subscribes to many worlds is going to think about the universe in a different way than someone who subscribes to, say, a pilot wave theory.
Wait, what's that one then?
Pilot wave interpretation says, the question of particle or wave is answered with both. You have particles that are guided by waves. In the double slit experiment, the wave goes through both slits, the particle goes through one slit, and then the wave interferes with itself, and that affects the motion of the particle and builds up this interference pattern. And if you put the detectors on each slit, well, that affects the waves and destroys the interference pattern. And there's nothing super mysterious about it. It's just a mechanical interaction.
Yeah, that makes sense. Like, solved. Can we go home? That's it. Go
Sure.
home, quantum physicists.
Yeah, but there's always a price to pay, right? The price that you pay for the many worlds interpretation is, the many worlds. The price that you pay in the pilot wave interpretation is twofold. First of all, there is strange long distance, faster than light connections between things. So
So just the faster than light connection is like the spooky action at a distance, right? The Einstein, whatever. But that exists as well. We know that happens. No?
We do know.
Did I read it wrong?
Yeah, that's right. Yeah, and so this is...
what's the problem? Like, that
right,
happens...
No, well, so now you sound like a pilot wave person, which, again, I think that's a perfectly reasonable... I think that's a perfectly reasonable option. The pilot wave people would say, yes, no, the explicit long-distance instantaneous connections, that's a strength of the pilot wave interpretation, because it makes explicit this, this stuff that we already know happens because we have experiments that show that spooky action at a distance is real. Quantum entanglement is real.
Can I do it at home? Can I entangle stuff at home?
You can't do a Bell experiment at home. Not easily. But you can entangle things at home. Entanglement is actually something that happens all the time. That two things get entangled in general whenever they interact. It's what powers some of the ways in which we get like normal everyday behavior out of the strangeness of the quantum world. And also in the many worlds interpretation, this is what powers the splitting of the universes, right? You look in the box to look at the cat, you get entangled with the cat by doing that. And so before you open the box, there are two cats, but only one of you. And then when you open the box, now there are two of you because you got entangled with the cat and then you split. And then your friend comes in the room.
Explains that you don't need any of this multiverse stuff. Just go with the pilot wave, it's fine.
Sure, yeah, but if you want to go with the pilot wave, then you have to deal with the fact that like you can't explain things like results from particle accelerators, right? You don't have a good way of understanding things like the Higgs boson.
It's beyond. It's gone beyond what I can understand.
What does all of this mean? How do we tie these ideas together?
You know, ultimately there are different competing interpretations of quantum physics, which is our best theory of basically everything in the world. And that means that at a certain level, we don't know what's real. But we do know that quantum physics works extraordinarily well. So that means that there has to be something in the world that is ensuring that the predictions of quantum physics come to pass. We don't know what that is yet. We have ideas about what it could be, but it's the job of physics to find out.